All right, so I think we can get started. And we're going to start from a point of, familiarity. We want to start with something you guys already know. And TikTok is restricting me to sharing only the windows. So the folks on TikTok, if you want a better display, you can hop onto YouTube. The display there is way much better. Let me just share the link in the chats. Yeah, so YouTube will be much better on the display. So uh, we are going to talk about cloud computing today, and we want to start from we want to start with what we already know. And what we already know is you go to a browser and you want to visit a page, so you type www.somastories.app. So what that does is it goes to the backend and then it tells the backend the information that you want. So let me just say here story details. As well, I'll just say here story details. Now, for those wondering what I'm talking about the story app. That is what we are going to use as our reference. It's because I have personally developed story app myself from scratch, and therefore it's I understand it in detail for me to be able to talk about it and to explain how it works. So you go to a browser, you type somastories.app, and then you get the story that you want to read. Now, we said the most important thing you have to learn is the client server architecture, and that is whatever is making the request. If it's a mobile phone, if it's a website you're on, if you are trying to access any website, you in that whole arrangement is what we call you are what we call the client. So your browser makes a request to the backend forwards your request to the server, or rather to the database, and you get the data that you want. It's important to note that the server in this case is not something in your house. So the computer is what you have in your house, that is your laptop. Now, the files or the website is not hosted in your house. The website is hosted somewhere else, the cloud. When we say in the cloud, we mean it's hosted somewhere else in a data center on somebody else's computer. So we can draw that schema here, or that sort of diagram here. So let's say, for example, this is why am I not typing? Oh, it's too small, my goodness. Let me just reduce this. All right, so this is the Soma Story server, and we can call it server 1, and server 1 is located in North Virginia. What am I typing? My goodness. It's located in North Virginia. Now, North Virginia is like in the US, and you are making a request. You are right here in Kenya, or for example in Zambia. So you are in Zambia and you want to access the Soma Stories website. What you do is your browser will make a request to a server. So we do have a server right here. For example, this is the server hosting Soma Stories. This is the server hosting another website, and so on and so on and so forth. So you can just put them right here. All right, so your computer will have to make a request to this server asking for the information that you want. Now, remember we said before that information gets to the server, it first goes through a few things. Like, for example, it will go through your router, your home router. So right here, you have your home router. Let's just find a router icon here if you have one. Let me see. I do not have a router icon, so let me just draw it. So this is your home router. It was given to you by Safaricom, okay? So we say this is Safaricom home router. Now that home router does not forward your request directly to the server, because it has to go to, Safaricom's, can you say backbone connection of internet. So what happens is you have another router, and you have another router, and you have another router, until you get to the router that is right at where your server is. So this is the Soma Stories server. Okay, so we can just label it so that we understand this is the Soma Stories server. So this is the Soma Stories server, and this is what we call a data center. Data center, is that how data centers you write a data center? Okay, I think the spelling is correct. All right, so so these are routers, and your request will have to go through all these routers to get to where the server is and get you the website files. Okay, so we can just draw arrows here, a bunch of arrows. Let's draw another one here. I think I'll just copy paste. Right, like so, until you get to now whatever you want right here. So this is what we call the client server architecture, but in a broader sense. So that means when you type any, so this is Safaricom router, home internet router. So we can label it like so. We put it right there. So that means whenever you visit any website, and we can just change this to Kenya, since already we've talked about Safaricom internet, and this is sort of what we have. So in a data center, you will buy a server. A server is basically you buy a computer, but it's a computer, you don't access it on your, you don't access it physically, in your house, like you have your laptop, you have it there physically. But in a data center, you buy a server and you look at that and you access it, we say remotely, using your laptop. So this is the client server architecture. Now a few questions here. We need to ask ourselves a few questions here. If you have a data center in, let's say for example, North Virginia, and you are making a request from a laptop somewhere in Mwihoko or in Kiambu in Kenya, your request will have to go through all these routers, and you can just label them as R1, R2 up to, this is R1, okay, R0. So this is router 1, this is router 2, this is router 3, and so on and so forth, until you get to the main router, which is next to the server that you want to access. Okay, now imagine you have another server. Let me just zoom out and copy this. Now imagine you have another data center, but this data center is right here in Kenya. It's not in North Virginia. Okay, it's right here in Kenya. Now instead of your request going through how many routers, 1 2 3 4, it goes through 2 routers, and you can just put them here, and we'll duplicate these as well. So instead of your request going through 1 2 3 4 5 routers, it will go through only 2 routers. Now you would imagine it takes a little bit longer for this request to work than it takes for this request to work. Okay, so for example here it might take say 20 milliseconds, but here it will take about 100 milliseconds, because your request is going through so many hops. We call them hops. It will hop from this router, it goes to this one, it goes to this one, to this one, until it gets to your website. But if you're hosting your website in Kenya, in a data center in Kenya, it will only go through these 2 hops. So that is basically the essence of cloud computing, is trying to take whatever we've built locally and sending it to production, and we we do it in such a way that we call it low latency. The requests are fast, and also we do it in such a way that there's, your website does not crash, or when a lot of people are making requests, or when a lot of people are trying to access your website. So that actually forms the basis of software engineering. As long as your software is reliable, as long as your software is, it's fast, as long as it's secure, nothing else matters. Only those, I think it's 4. I'm forgetting the 4th one, but only those 4, parameters do matter. So let's now jump into the code editor. Let's build application locally, and let's try to deploy it to the cloud. Now, before that happens, when you're developing your application locally, you can only access them locally on your laptop. So right now, I do have my, this is the demo we looked at the other time, the auth demo. And it's just a web app that allows people to log in, to register, and to do all those kind of things. So I will fire up my front end and back end. So first I'll cd into my back end, cd backend, and then I will activate my virtual environment. So I'll say python -m venv venv. And I'm pretty sure the folks on TikTok are having a hard time. Let me just see if I can zoom in a little bit up to this point. All right, I think that looks better. Yeah, that looks okay. So I will activate my virtual environment, and after I've activated my virtual environment, I will go ahead and install my requirements. So second, so while that's happening, I will also jump into my front end. So I will cd into my front end, and then inside my front end, I'm going to do npm install. All right, so the virtual environment is installed, but it's not activated. So we'll go ahead and activate it. So I think the command for activation, I can just copy this. Where is it? Scripts. I don't know which one it is, but let me just see. So I will do that, venv scripts, and then I'll say activate. What did I miss? Oh yeah, I cannot run commands in PowerShell like so. So let me just shift over to, let me just copy this. And I will close this. So right here in my backend, I will cd backend, and then I will activate my virtual environment. Now my virtual environment is active. I'll go ahead and install my requirements. So I'll say pip install requirements, but first I'll do pip install -r requirements.txt. So while that is going on, we'll hop over to front end and confirm our dependencies were installed. So after that is done, you're going to do npm run dev. And we need to have a readme. I don't think we have a readme here. So we'll create a readme. We'll create a readme.md. Readme.md. So readme.md will basically explain the steps it takes to run your application. So here we'll start by to run backend. You need to run python -m venv venv, and then you need to run pip install. To activate the virtual environment first. So we'll just paste that, and then you need to run pip install -r requirements.txt, and then down here we'll say to run the front end. I need to cd into front end, npm install, npm run dev. So our front end is running okay, as you can see here, and we can access it in the browser. Unfortunately, if you're on TikTok, you will not see my browser because there could only be so many windows I could share. I, however, do encourage you to check out the YouTube live instead, where the display is a little bit better. All right, so our front end is working okay. Let's go ahead and see if our back end is working. We've only installed the dependencies, so now let's go ahead and run the backend. Now I have forgotten the command to run Flask application, so let me just go ahead and look for that command. So let me just close all these out, and close that. So I'll go ahead and say fast API, fast API, get started. Where is get started? Documentation. Oh, this is the documentation. all right. My goodness. Installation. So once you've fast API dev. So this is fast API dev. All right, so we can put that in the runtime error pip install. Okay, we had not installed that, so let's just install it. Backend. So we can just add it there, and then you say fast API dev. Let me just remove the spaces here. So if you're wondering what's going on here, in the previous article we talked about building a web application that has a backend and a front end. There's a guide to that on my Soma Stories blog, where you can go through and build your own full stack application from scratch, both the backend and the front end. So that is just what we did in a previous session. So I'll give it a second for Flask to I for 1522. Thanks, man. Thanks a lot. All right, so once we've done installing fast API, so let's go ahead and try to run it. Fast API dev, and yeah, our backend is running. So right now, if I want you to access whatever I've built locally on my machine, you cannot, because it's running on my machine. Only anybody in the same Wi-Fi or on the same network can access whatever it is I've built locally on my laptop. So how can we take this and make it available, for everybody else in the world? So if you're just doing a demo and you want to showcase what you've done, you can use something called Ngrok or Jirok. It's called Ngrok. I know. It's called Ngrok or Ngrok. Let me see. Ngrok. Yeah, if you want to host something from your local laptop, you can use something called Ngrok, okay, or Ngrok, to make your application available to the world. And you can have a look at that. Let me just go ahead and try to do that. So let me see. Login. Okay, I'm trying to log into Ngrok. So let me just log in right here. MFA. Let me see if I have that MFA turned on. Let me see. MFA. Now, where's my Authy? Authy? Ngrok. Where are you? right, 541,880. So here's what you want to do, just to clarify for those who joined late and for those who are a little bit confused. We have built our front end, which is running locally on our machine right here. And we've built our backend, which is running locally on our machine right here. We can confirm that both these services are running, port 8000 and port 3000. So if I go to the browser right now and I type 127 3000, I can see that my front end is running okay. If I go and try to access the backend, I can see the backend is working okay. I'm typing the wrong address, that is the correct address. So I can see our backend is running okay. However, these things are running locally on my machine. If I take this link and share it in the chat, you will not be able to access the front end or the backend because this is a local environment, okay? So for me to be able to host my website so that everybody else around the world can access it, I have to host it on a server. But before we host it on a server, we also want to explore this local tool that allows you to host services from your laptop. So I think I've lost, oh, it's right here. So to install, we can just run the following command to add your authentication token to the default Ngrok. All right, so we can download the installer right here. This will ask me to sign up, and I do not want to sign up to Microsoft, but let's see if it will work. Ngrok. All right, installing. Yeah, looks like it's done, so we can open it. So once Ngrok is installed, let's go ahead and copy this command into our VS Code. So I'll open CMD and I'll type it there. Save to configuration, that's okay. So if you're watching this on TikTok, I'm not able to share my entire windows, my entire display, so you might have problems trying to figure out where I am. For that, I encourage you to use the YouTube live, which is yeah, and I can't paste a link in the charts. Ooh, screw TikTok. Anyway, just go to YouTube, search Moses Mbadi, and you'll see the live there. So once that is done, I can go ahead and copy this command, Ngrok HTTP 80. Go to your dev domain to see your app. So I will copy this. But instead of saying HTTP 80, oh my goodness, where is the command? Ngrok HTTP. So I'll say Ngrok HTTP. And then I'll say 3000 because I wanted to host my I wanted to host my front end. So I will copy this link and paste it in the browser just to confirm it's working. I'll paste it here. Visit site, of course, it throws that error, and as you can see, I can access my project. So to test this out, I'm going to paste the link in the charts. Just go ahead and click the link and see if you access the same thing right here. So I've pasted the link in the YouTube chat. I'm not able to paste links on this on TikTok. But if you're on YouTube, you can have a look at it. So yeah, we have achieved some sort of cloud computing because I have successfully run this project locally on my machine, and you guys can be able to access it. In that case, my computer right now is sort of like a cloud server. Okay, you can access the link, you can try to do whatever. Brain Mugangashi, thank you for confirming. So at this point, my computer is like a cloud server. But you might ask yourself a question. So why can't we just host a website on our laptop or on our computer instead of buying an expensive server? It's because right now you can only access the front end because I have it running. As you can see here, you see all this? You see all this? I have it running here. If I kill it, if I do something like, if I kill my front end, I come here, I press Ctrl C, terminate batch job, I'll say yes. Now, can you try to access the same link again? You'll notice that you cannot access it, okay? It's because, for starters, your laptop or your desktop was not designed to stay on 24/7. Okay, you'll ruin your laptop. It will get it. You'll have issues. So your laptop is not designed to stay online 24/7. As you can see here, if I shut down my computer right now, you'll not be able to access the web page I sent. Equally, if I kill the front end like I've done right now, you'll not be able to access it. So that is where now cloud computing comes in. And now we are getting to the fun part of this class. So first things first, we want to buy a server, and the server we are going to buy is on AWS. I'm going to create a whole new account. Sometimes creating an account, has its own issues, but we'll just give it a try and see what happens. I'm hoping it won't ask me for confirmation or whatever. So let's just go to the browser, and I have to add another source on. Let me see. So AWS. So I have to add another source on TikTok. So if you're on TikTok, you can check out the YouTube live, which is better because it shares my entire display. So here I'll say Windows Capture, add. So the source is AWS, capture cursor. All right, so now we'll go ahead and register for AWS and buy a server from them. Now, cloud companies like AWS, Azure, DigitalOcean, Google Cloud do give you an interface where you can buy a server, or we can say where you can buy a computer. So that is what you're going to do right here. So first I'm going to register for AWS. I'll say create account. And I want to do this. Let me see. Verify email address. So we are going to use Soma Stories Gmail. So that is Soma Stories at somastorieske@gmail.com. Choose a name for your account. So you'll just say Soma Stories. I will say verify email. So we'll give it a few seconds. Of course, I'm not a robot. So that is 5. Is that capital P or small p? That's how they get you. 853X. I hope that is small x. So I have to verify. So let me just get the code. Let me see if the code is here. Verify. So the code is here and it's 685. Why am I saying it out loud? You guys will steal it and try to do all sorts. Okay, so root password. What password should we use? I'll just use a password generator for this. Password generator. So I'll go ahead and copy that. I'll paste it there. I'll paste it there. Show password, continue. Let's save. So we can start with a free 6 months trial, which gives you $200 of credit, or you can just jump onto the paid plan. For now, we can just use the free plan. So I'll just say choose free plan. Yeah, so let's go ahead and feed in this information. So we'll say Moses Mbadi. The country is Kenya. Country is Kenya again. Why do I have to do this twice? Right. Oh, state or province. I'm in Nairobi. Wait, I'm in Kiambu, but anyway. Must I add in the card details? My goodness. All right. So, yeah, let me get my wallet and we get this going. All right, let's continue. You see why I keep telling you guys to donate to this course, because I'm not just going to teach you theory, I'm going to teach you practicals, and I end up spending my own money in this thing. So I'm going to hide my card details. I don't trust you guys. So let me hide my card details. What's the expiration on this thing? Okay. That's it says there's an error processing my request. I do not know why. Okay. Okay, I don't know what's happening. It's refusing to process my card. That's the correct. Okay. I don't know. It's refusing to process the whatever. So what I'm going to do is I'm going to use my existing account to purchase a server. Oh yeah, the new M-Pesa app has that global pay, but I'm not very sure AWS accepts prepaid. That card is a prepaid, if I'm not wrong. I'm not sure if they accept prepaid, but I'll give it a try. So I'm just going to log in with my other AWS account, and then we can continue from there. So let me see which website the TikTok gang is seeing. So we'll type AWS. I'll just sign into the console. I need to have my OTP ready. Okay, they're sending me a welcome message, yet they have... Oh! Okay, turns out it worked. For some reason, the registration worked. So let's go ahead and try to buy a server. So every cloud provider, be it AWS, be it Azure, they all have... I'm trying to move this to the top. So every cloud provider has different services they offer. So think of when you're going to buy a laptop. It's not a laptop you always go to buy. Sometimes you want to buy a USB drive, or you want to buy a hard drive, or sometimes you just want to add some more space to your laptop. All these are what we call computing services, and most of the cloud providers do offer that. They also offer storage services, and believe it or not, you have used some level of cloud computing. Google Drive is a good example of cloud computing. What else? things like Gmail, but these are what we call software as a service. So you are given the software. Now, in our case, we want the platform. We don't want the software. We want the infrastructure, the platform. We want to deploy our application there. So if you go to AWS, it can be a little bit overwhelming at first because you don't know what is what. Again, I have to maneuver the thingy on TikTok. Oh my goodness. TikTok gang, do you see the amount of work I have to go through so that you guys can... Anyway, I hope that is better now. So if you're watching on TikTok and you've just joined, TikTok is a little bit messed up because I can't share my entire display on TikTok. So just go to YouTube, search Moses Mbadi, and you'll see a live. Join it there. You'll see everything. So back to our what we are doing. So I'll go to the icon right here. And as you can see, all these services are offered by AWS. There's network and content delivery. I will not jump into all that. There is compute, so we'll click on compute. And then inside compute, not inside, oh my goodness, under compute, we have all these. So we have EC2, we have Lightsail, we have Lambda, we have all these things. And don't try to cram everything here. Just understand what you need for the specific service that you want. So let's have a look at what powers Soma Stories from AWS. So let's just have another diagram right here. So again, I have to, oh my goodness, I have to move this to the top like so. No, move it a little bit higher. All right. So this is the architecture of Soma Stories, the mobile app or the website that you use. So we do have several servers. By several, I mean 3 servers. So we have one server, which is the main API, and we have 2 more other servers. Let me just say this. So this is our backup server. We call it backup server 1. By the way, have you guys watched that TV show called Mr. Robot? I really think you should watch that show. And then we have the main server. So MN server 1, that is actually server 0. And then we have MN server 2. So this is the main API server that stores the stories, it stores the users. So if you are fetching stories right now, you are fetching from this server, okay? And the alias to this server, I call it API server. And you'll just look at how to do that in a second. And then we have this other server called Mobi. So if you've signed up to Soma Stories and you have received an email asking you to verify, or if you have received a weekly digest email, or if you have received a push notification, that comes from this server here called Mobi. Everything else, the stories, the user accounts, the tokens, all come from this main server right here. Now, I do have another server which handles our front end. So I will just copy this. I'll put it here. So this is, I think it's called Web Server 3, if I'm not wrong. Web Server 3. Now, this is what handles the Soma Stories website. So if you go to www.somastories.app, everything you see is being handled by this server right here, okay? So this is what we call our client-facing server, right? And you can just put it right here. So this, in short, what I'm trying to draw here is what we call a cloud architecture, or just basically the architecture of your infrastructure to host your application. So now, once I have that there, we now have the client, which is anybody else trying to visit the website, okay? So you have somebody here in Kenya, you have somebody here in Zambia, you have another person right here in something like Uganda or Nigeria, okay? So all these people are making requests to this one server right here. So all requests, hey, I want the story titled this. Hey, I want to withdraw my tokens, perform a withdrawal request. Hey, I want to top up my account. All these requests are handled by this one server, okay? Now, this server determines what exactly is being required. So if you want stories, you will send a request something like get stories, something like this. So you'll say, hey, I want you to get me stories. So for example, somebody in Zambia will want to withdraw. So this will be withdraw. And then somebody in Kenya would want to top up. So this will be top up. Top up, right? Let's just use the appropriate name. This is top up. So all these requests are going to one server, and there's something very, very extremely important I want you to pay attention here. It's not one person in Kenya making a request to your server, okay? It's not one person in Zambia making a simple request to your server. It's not one person in Uganda making a simple request to your server. And here I've said, so this will be handled by our main server, okay? So get me stories, perform withdrawal, do everything. So these two servers, this one just serves as a backup. This stores copies of both these servers right here. So if we do something like this, we can just say this performs a backup. So whatever is here, it's backed up here, so that if this one dies, I can just take this one and make it my server. So there's something very important I want you to pay attention to here. This is just a pictorial whatever of the request and response flow. However, in the real world, you have tens of thousands of requests, each coming to this same server, okay? So you have, let's say, for example, 10,000 requests from 10,000 requests from Uganda, you have 10,000 requests from Zambia, and you have 10,000 requests from Kenya. If you do a calculation, assuming these requests are coming within 10 minutes, here you're dealing with 30,000 requests per minute. This is what we call requests per minute. So we'll say 30,000 requests per minute. All right. So for your server to be able to handle 30,000 requests per minute, it has to have enough resources to do that. Okay. Enough resources in this case mean it has to have enough RAM. It has to have enough RAM, CPU, but in the cloud environment we call it vCPU. So vCPU. Storage not that much, but you can just say disk space. All right, or storage. So let me just do this. Let me do this. All right. So for your server to be able to handle all these requests, it needs to have enough resources for it to be able to handle the request. However, inside your server, your application is running, and your application also needs to handle 30,000 requests per minute. Okay. So the power or how robust your service or your website is depends on two things, and it's categorized in two in sort of like in two ways. Number one, it's the platform where your website is running. So for example, if your website is slow, somebody might ask you, what kind of a server is your website running on? Is it a server with 16 GB of RAM? Is it a server with 4 GB of RAM and things like that? How many vCPUs does it have? Does it have 2 vCPUs? Does it have 3 vCPUs? Now, your server can have all the resources you want. It can even have 24 GB of RAM. However, if your application is not designed properly to handle all those requests, then the server becomes just useless. It's like, for example, if you, how can I explain this? I can't find the right analogy to explain what I want to explain, but you do get my point. So pay attention to this thing here. It's called request per minute. So before you deploy your server, your application, your website, always ask yourself, how many requests can your service handle? And I'll give you an example. Soma Stories, I have done some tests on it, and it can handle 10,000 requests per minute. Okay, it's it's ironical that I'm talking about 30 requests and I can only handle 10,000, but I can only handle 10,000 requests per minute comfortably without struggling. Okay, so there is that. So this is where performance comes in. When you're designing web applications, when you're deploying web applications. Now, there's also something very interesting I want you to pay attention to. We've said that if your user is in Zambia and the server is somewhere in North Virginia, or South Africa, for example, South Africa. All right, let's just do this. So in the cloud computing space, this is what we call regions. You'll hear me say, I want to put it in this region. I want to put it in that region. So this is what we call region. Now, between these three people, I want you to think about it. If they make a request at the same time, if they both want stories, who do you think will get stories the first? If the server itself is hosted in South Africa, who do you think will get results first? All right, I'll give you a minute to think about it. So you have a user in Uganda, you have a user in Zambia, you have a user in Kenya. They are both making the same request. They want stories, and the server is in South Africa. Who do you think will get the results the first person? English is hard. Anyway, it's this person in Zambia, because geographically, the server is closer to this person in Zambia. So this person will get results the first, and then maybe the Kenyan, and then maybe we go to Ugandan. So if you have another user, for example, in Egypt, all right, in Egypt. So if you have somebody else in Egypt and they're making the same request to our server, all right, and they're making a request to our server, this person in Zambia will get the results almost 300 milliseconds faster than the person in Egypt. This is what you call latency in cloud computing. Like, how long does it take your service to perform a specific task being requested by the user? So there are a few ways to handle this. For example, you want this person in Egypt to get results as fast as this person in Kenya. That is where we have other technologies such as CDN, which basically takes this server and a copy of this server or the files inside it and puts it on a server near Egypt, so that the person in Egypt can access the results faster. All right, any questions? Is that well understood? The issue of latency, the issue of performance, the issue of requests per minute, the issue of server resources, RAM, vCPU, disk space. The issue of, I've also pointed something interesting here, that a single website can have more than 10 servers behind it, okay? All right, so now this is all good, but you might ask yourself, how about a website that handles 1 million requests a minute? Okay, how about something that handles 1 million requests a minute? If you want to handle 1 million requests per minute, what you need to do is, okay, this is just at the low level. We are not really diving deeper. So let's assume Soma Stories handles 1 million requests a minute. What I'll need to do is I will need to add another server here called a load balancer, and we can call it LB. So what the load balancer will do, it will get the request and then it finds the server that is not busy. For example, I'm trying to delete these and my goodness. Okay. So instead of having one website or one front-end facing server, we'll have multiple servers here. Okay. So we can call it, this is web This is web L0, and we can say this is www.somastories.app. All right, so we can minimize this. And this right here becomes what we call a load balancer. And by the way, a load balancer just does exactly what it sounds, or what it, what you think it does. It balances the load. Okay, it balances the load. So instead of having one website, one client server here, we can have 3 client servers, right? So we can have L0, we can have a web L1, we can have web L2 as our third server. So what this load balancer will do, this load balancer gets all 30,000 requests in 1 minute. But what it does is it checks on these servers and finds out which one is less busy, which one is handling less traffic. That is just one strategy it uses. There are a couple of other strategies, but we can just focus on one. So what it does is, for example, your previous request went to this server. Let me just change the color, So your previous request, okay, that doesn't, okay, I don't know. Let me just do this. All right, so your website, somastories.com, got 10,000 requests in 1 minute, and all those 10,000 requests went to this server right here. Now, if you have somebody else making another request, okay, not really somebody else, but you have 20,000 requests coming from Egypt, this load balancer will not send all those requests to this server. It will send it to this server right here, okay? When this server becomes full, or when it becomes super busy, it sends the request to another server. So this is what you call load balancer. What you see here is just an application you install on a server, right? Okay, any questions? I hope this is well understood. The concept of request per minute, the concept of latency, the whole idea of having multiple servers for one website. All right, let's move forward. Okay, I think I've lost my chain of thought, but let me recollect. All right, so we want to deploy our application, and we've said we now want to shift our focus into here. We want to purchase a server, okay? And we want to load balancer server does not, the load balancer does not get overloaded because it doesn't process the actual request. It just routes, okay? It gets the request and processes it. Think of it as a receptionist, okay? The receptionist gets a lot of visitors, but he does not handle all those visitors. He will tell you, oh, you want to go to billing, go to door number 3. You want to go to finance, go to door number 4. Now, in billing or finance, it might take you longer because, for example, in billing, you're trying to buy something, okay? You're trying to, so for example, you'll ask the price, you'll get the money, you pay with M-Pesa, get the receipt and whatnot. All that happens in billing. But you see, the receptionist did nothing else. He just did, the receptionist just directed you to the person who can handle your request. So the load balancer does not get overwhelmed because it literally just checks which server has space and, routes the traffic there. It doesn't really do much. All right, so we are now here. Let's go ahead and buy a server, our remote computer, and it's going to be a very heavy session. So I want you to pay attention, okay? I want you to put all distractions aside. We are going to, look at some very, 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 very complex stuff, and you're going to deploy our application to one of the servers. So first, let me make my. I think I need some coffee. So let me get a cup of coffee, and I come back. We proceed. In the meantime, do shoot your questions in the chats, or do go ahead and try to look around. If you want, there's a written version. Okay, it's a brief written version of this tutorial or this class up on Soma Stories. Let me just get the link. Where is the link? Where is the link? All right, so the link to the written version I've pasted in the chats. You can go ahead and look around. Do make a cup of coffee, by the way. As you know, I stretch. All right, so I have decided I'm not going to take tea. I'm going to take this is ginger and lemon tea, not coffee. Sorry, not going to take coffee. So I'm going to take you guys through how I make my ginger tea. Yeah, there are quite a lot of animals in my house. So. All right, let's see. So we have the tea. Put it in here. So fast, I think I take a lot of sugar. I need to stop taking a lot of sugar. But I only use a very small amount. So I'm just going to... I put in some honey. Very important. Just a little bit of honey. All right. Why can't the lady help you? Yeah, the lady traveled. So we have some honey and then some ginger. I'm adding, an extra scoop of ginger. And for the men for the men in here, you need to Google about the importance of ginger. It increases blood flow. Need I explain? It increases blood flow. So, so you people keep saying, hey, Luya man, I have given you the secret. Now go ahead and try. All right, for those joining us on TikTok, we're also live on YouTube. And on YouTube, you'll see a little bit, the screen is a bit bigger. So just go to YouTube, search Moses Mbadi. You'll see a live session. Go ahead and join that. You'll have a better experience there. So TikTok is limiting, how much I can share. So I can only share a small window, which kind of sucks. I mean, wonderful. The only problem is I'll start sweating here, and I don't want to start sweating. All right, let's continue. Let's buy a computer remotely. Let's host our application on that computer. So we'll go back to AWS, and I'm using AWS. You can use any cloud provider you want. You can use DigitalOcean. I personally host a few websites on digital. I personally host something on DigitalOcean. You can use Azure. You can use Google. I think Safaricom also has hosting solutions, but I mean, if they can design an app as shitty as that, can they really host my super duper well designed, well thought after application? No. Anyway, so under compute, and this is something you really need to bring in AI to help you with the decision making. So I do have a website. I know for a fact I can host a website on Lightsail. I can host it on EC2 instance. But if you are confused, do some research. Find out which is cheaper. So if I go to, let me just show you DigitalOcean. So if I log into my DigitalOcean account and show you the servers I have there, I can't remember the account I need. Oh my goodness. Is it this one? Let me try. So let's see. Yeah, and I'll also show you how to secure your cloud account. If you don't secure your cloud account, somebody will hack it and they will run you dry. So I have the Soma Stories API here, and this is just a server. It's 2 GB of RAM, it's 60 GB of disk storage. So DigitalOcean is a little bit straightforward because once you log in, you can see all these things here. A droplet is when you need like a computer. And then you have all these things like databases, like if you want a database and all that. So if I go to this droplet, for example, and I want to create a droplet, create a droplet. So we can scroll, like you see this thing I was telling you about, the region. Oh my goodness, I forgot to switch the display on TikTok. Okay, so this is what I was talking about the region. So DigitalOcean does not give you a lot of regions. If you're in Africa or if you're in Kenya, you might want to go with something closer to Kenya. I don't know which one is closer to Kenya. Bangalore, maybe, I think, or Singapore, I think. And then you have the data center you want the region to be in. And then you have now the type of the computer you're buying. Are you buying Ubuntu, Debian, CentOS? All these are operating systems, and you'll just dive deep on how to work with them. And then you choose the version, and then you choose the specification. So if you want 4 GB of RAM, 120 GB of hard disk, 2 CPUs, you can go with this one. But you can also buy this one, which is affordable if you want to play around with it. So DigitalOcean also gives you $200 credit that you can use for 3 months. So you can go ahead and sign up and look around. Okay. So we want to do a benchmark of something like this. Okay. So this is 2 GB. Intel CPU, and it's 70 GB SSD. So let's find a computer on AWS that is similar to that. So like I said, you can bring in the help of AI to help you decide what you want. Okay, so if you want to host a website, you can just ask it. I think I was struggling to let me just close this. I think I ran out of let me try Gemini. So right here, you can come and ask Gemini, I want to host a Next.js frontend on AWS. What services do I have? Or what services can I use, or something similar. So of course it will think how to handle data loss. What kind of data loss are you talking about? Maybe you can clarify. So Gemini is telling you can use AWS Amplify, you can use containerized hosting, you can use OpenNet, and that's about it. Now you see, this is why, and I just want to advise people getting started in tech. Forget about the AI hype, okay? AI, of course, can help you speed up a few things, but it can be very misleading. And this is an actual example of how AI can be misleading. You see, of all the options, just to clarify, let me go through again. Of all the options Gemini has given you, it has not given you something called AWS Light Sale. And AWS Light Sale is like super cheap, and it has it has a price that is predictable, that for a fact I will pay $100 at the end of each month. But all these things Gemini has suggested, even though they're okay, they can work, but it missed out on something very important, on the price element. To host 30 requests per minute, do you like host the backend on a different server? Yeah, highly advisable, and I'll get back to that in a second. So Gemini has clearly missed something important, which is what you want to do. So on AWS console, there's this thing called Light Sale. So you're going to click on it. I need to okay, so let me just log in with my normal AWS account so that we can proceed. So let me sign out of this one. Let me sign into another one. All right. Security, very important, very important. Let's look for that code. Where is it? Where is it? Oh my goodness, it's not here. Oh yeah, I see it. All right, so I hope in your case the registration will be simpler, but for now I'm going to use my existing AWS account. So on AWS, like I said, it will show here the services that you visited the most. So in my case, I have all these services I'm using for Soma Stories. As you can see, I have S3, IAM, all these things, and we'll dive into all of them as we proceed. But if I come here, I have Light Sale, I have EC2 instance, I have, all these things. So I'm going to click on Light Sale. All right, so once you click on Light Sale, as you can see, I have quite a few servers here. I have this one in Mumbai, this one is in Mumbai, this one is in Mumbai as well. So I don't think I can create 4 instances at the same time, but let me go ahead and try. So I'll create an instance here, and then I'll say I want it to be a Linux, because we host applications on Linux servers. Forget about Windows here, Linux. So we'll say we want it to be Linux. We want it to be operating system only. So as you can see, you can create quite a bunch of things like OpenClaw, WordPress, Joomla, GitLab CI, and all those. But we'll say we want it to be software only. We want it to be Ubuntu 24, and then we can scroll down up to this. We can go with this one. Let's see, are we missing anything? No, we're not missing anything. We can scroll down. Instead of Ubuntu 1, we are going to say 8 hours 01. 8 hours 01. Once that is done, we'll say create instance. Oh, I didn't know it will work. So now it will create the instance. So what we've just done here, we've rented a computer in the cloud, okay? And I think I can just draw what we've done so far. Again, once I switch windows, I have to go to TikTok and move the it's quite a headache. So let's draw an architecture of what we want to do, okay? So locally on our laptop, we have developed the auth demo application. The auth demo. This is called auth demo. But the auth demo is only available on our laptop. Somebody else in another country, like for example, if you're watching this from South Africa or wherever, you cannot access our application. So I can just say Uganda, for example, you cannot access our application because on my desktop, I'm not allowing you to do that. And my desktop is not like a server, okay? So what we've done, we've gone to AWS, and I can just draw that here. So we've gone to AWS. Let me do that. So we've gone to AWS and rented a small server. Let me just copy this. We've rented a small server. Just think of it like a small computer, okay? But there are a few things to note here. Where is our computer located? So we can go back to AWS and find out where our computer is located. So as you can see, our computer is located in Mumbai. So we can come here and say our computer is located in Mumbai. All right, so we can put Mumbai in here. Now, what have we named our server? We have named our server as 8 hours 01. So that is the name we've given our server. And what will the server host? The server will host the front end and the back end. In our case, we are putting both the front end and the back end in one server. So what happens is you take your application from your laptop and put it on this server so that somebody in Uganda or in Egypt can access your application. And basically that sums up cloud computing. So you're done with the class, with the course. All right, so let's go ahead and find out if our computer is done provisioning. So as you can see, it was saying starting, and now it's changed to running. So let me just look at a question here. Oh yeah, so somebody on TikTok had asked how to add GDPR to the application. If you don't know what GDPR is, it's the General Data Protection Regulation. I think it's effected in almost every country now, and it's not more of adding it to your website. It's more of being compliant to the GDPR policy. So one of the ways you can be compliant is you minimize the amount of data you collect from a user. So you'll see at our registration, we are only collecting the email and the password. We are not collecting the phone number. We are not collecting the ID. So one of the compliance, whatever, is to minimize the amount of data you collect. The other one is to give people an option to delete the data that you have, okay? If right now I do not want to be on Facebook anymore, I want to get out of Facebook, I need to have a way to delete my data or any other platform for that matter. All right. The other thing is also consent. You have to tell the user that you want to collect this data and that data and that data. If the data, if your server is hacked and somebody gets access to your data, you need to tell your users that your server was hacked and you lost data, you lost emails and passwords. One of the compliance, if I can just remember, is what? I've forgotten. I've talked about consent. I've talked about access. I've talked about deletion. So it's more of compliance. You have to comply to, the policies. Okay. So the part that they can get you is if somebody is doing an audit and they ask you, show us how a user can delete their data, and you don't have any way of a user deleting their data, now you're not compliant. Anyway, so our server is live. Let's go ahead and log into our server. So to log into this server, there are two ways you can do it. You can log into this server using your terminal, okay, without having to log into AWS. Right now, I have to log into AWS for me to access this server. So I can just come here and say connect. I've just clicked on this connect using SSH. I will expand this. And if you're watching on TikTok, I'm sorry, you cannot see the screen because TikTok is just a nightmare to work with, because I have to move between so many windows up here. Yeah, but let me just do that because we will need it. Let me just say window capture, add, and we want to capture this one right here. All right, so once you click on connect here, I'm trying to show where connect is, my goodness. Once you click on connect, you will get access to your server. Now, we are inside our server. This is a whole new computer. It's not locally on our machine. As you can see, it's saying that today is Wednesday, April 15th, 6 p.m. As you can see, my time is 9 p.m. It's because right now it's 18:24 in Mumbai. Let's just go ahead and confirm that. Let's say Mumbai time. Wait, what a minute. Why is it saying it's 11? Which region did I choose? Mumbai is on. Okay, I don't understand what's happening. But yeah, let's just go ahead and proceed. So our application currently is not on this server, and we need to bring our application into this server. Okay, so first and foremost, let's have a look at how we can maneuver, or we can navigate this server. So this is what we call Ubuntu server operating system. It's not graphical user interface. There are no icons, there are no buttons. This is all you get. That is why I was telling you guys, make the terminal your home, because now when managing a server, this is everything you get, nothing else. So let's go ahead and look around. So we can do something like ls to see the contents of the file. We can do something like print working directory. We can do something like who am I, and it tells you you are Ubuntu. And we can even create a directory here. We can say mkdir, we can say 8 hours. And if we do ls, we can see our directory is right here. Now, the other thing you also need to note is the settings for your server. So let me just move the other window up, the other one. So these are the settings for your server, okay? So for you to be able to access that server, you need to open what you call a port on that server. So right now, if I come to networking, I can see here only two ports are open, port 80 and port 222. This is the SSH port. This is what allows you to access your server. And for the love of God, don't you dare mess around with this, because you'll have a hard time accessing that server. And we have port 8080. So let's see what is running on port 8080. Port 80, sorry. So we'll get the public IP address, which is what is shown here. This is the public IP address. This is the private IP address. Okay. So I will copy this. I will paste it in the browser, and I will do port 80. Continue to site. Right, so nothing is running on port 80. Okay, so let's go back to the server. And now what we want to do is we want to get our website and copy it to this server. Okay, there are so many ways you can do that, but the quickest way to do that is to use Git and GitHub. So what I'm going to do is I'm going to take our code. I'm going to take our code and push it to GitHub, and then I will take it from GitHub and pull it on that server, if that makes sense. So I'll go ahead, cd into the main directory. I will do git init. Git init. So it says it has initialized an empty git repository. So once that is done, I want to create a git ignore that will keep track of all the files we do not want to add to git. If you look inside the frontend directory, you can see git ignore is already here, and I think it handles quite everything we want to do. Let's go ahead and look inside the backend folder. There is no git ignore, so let's go ahead and add that .git ignore. Let me just zoom in for our folks on TikTok. Yes, so inside .git ignore, there are a few files we want to ignore. Let me just clear this. One of the files we want to ignore is these two files, this one and this one right here. Okay, not really files, but directories. So I will say www pycache. Normally there's an AI thing that helps me. Okay, yeah, that one. And then we also want to ignore venv, so I'll say venv. venv, it's a directory. So once that is done, I think everything else will remain the same. Delta scripts. Oh, this is the virtual environment we created the other day, so let me just delete it. Like so. So let's go ahead and push our code to GitHub. But before we push our code to GitHub, again, if you don't understand GitHub, there is an article I wrote on Soma Stories blog that you can use to understand Git and GitHub. Let me just get the link for that. Where is Git and GitHub? Where is, oh yeah, contributing to your first Git. Let me just copy that and paste it in the chat. All right, so we will go to GitHub and create a repository. So I'll go to GitHub, github.com. I will create a repository, a new repository. This is called auth demo. Auth demo, checking availability, authentication, full stack app. I'll say create. And then we need to run all these commands except this one right here, because we've already run this command. So I'll just copy all this. However, I want to make some changes because I want to commit everything. So I'll just write a script here. I'll say instead of that, I'll replace with dot, and then I will cut, and then that is what I'll paste here. So we'll hit enter. Let's go back to GitHub and see if the code is there. So we'll refresh. Oh, something didn't happen. Something didn't happen. Let's just try that again. Where did the issue? Oh, it says this is already a Git project. How? There's nothing here. Okay, let's go ahead and see. Auth demo. I don't understand. Hidden files. So let's just delete this and try again. So we'll do git init. All right, we'll do git add. This is very weird. You've added another Git repository inside your current. Okay, there's a folder here with another Git repository. Let's find out which one. So we'll go to desktop, auth demo. There's another folder with Git inside here. Which one is it? This one right here. This is the problem. So we'll delete that. And we try our commands again. Not that. So I'll just copy this and repeat. I'll copy that. but I will replace this with that. So I'll cut this, I paste it here. All right, so let's go ahead and see if it was pushed. Refresh. Okay, what is going on here? What is happening? I thought I had deleted that thing. CLS. Okay, let's look at that folder one more time. I don't know why it's just doing its own things. Desktop. This one, auth demo. So we only have this git here. Front end. There's no any other git. Back end. There's no any other git. What if we search .git? Yeah, there's only one git. All right, let's just repeat the steps one by one. So we'll do git add, git commit, cloud deployments. We'll do git branch. We'll do git remote, but let me first check git remote -v. So if you are already pointing there, already exists. Okay, so let's just push our code again. Push. Okay, yeah, that worked. So we'll go back, see if you know the push was successful. Yeah, now the push was successful, but this seems to be a git folder. I don't know why. Yeah, this will be super challenging. So let me just go ahead and delete this thing. So I'll just go here. Or I can just try to go with it. So I'll get the link. I want to get the HTTPS link. So I'll copy this. And then I will go to our purchased or our rented server. And inside 8 hours, so I'll do cd 8 hours. And then inside I'm going to do git pull. And I will paste that link right there. Oh, not git pull, git clone. And I will paste that link. All right, so now we have successfully moved the project from our laptop to the server. Now let's go inside the project. So we'll do ls. We see auth demo is there. We do cd auth demo. We do ls. So we have to run the backend and the front end and see what happens. So let's start with the front end. So I will do cd front end. And then inside front end, I'm going to do npm install. Now it tells me that npm is not available. Let's first confirm if node.js is available. Remember, to run any JavaScript code, you need node. So I'll say node -- version. And it's telling me node is not installed. So I will go ahead and install node. So I'll just say sudo apt install node.js. Yeah, I'm having issues installing it here. So let me just go ahead and look for node.js in the browser. Node.js. I will say get node. I'm looking for Ubuntu or Linux. Okay, wow, these are the only options I have here. Let me try that. All right, so this becomes challenging sometimes. You might want to use what you call NVM. All right, so we have NVM. So I'll copy all this to the clipboard. I will go to my server and install everything. So don't try to cram all these commands or all these steps. what I want you to do is just have a general understanding of what happens before you deploy an application to production. So now that we have Node installed, we can try again and do Node version, and Node is there. So we'll say npm install. Now I want to run. What is not happening here? Could not read package.json error. No such file. Okay, we don't have package.json. Let me see. Package.json. It's right here. Let's see. Why is it not in the server? ls. Yeah, so for some reason, that Git messed with our project. So we have to deploy it in another way. So we have to, okay, not really in another way, but we'll have to create a whole new Git repo. So let me go ahead and delete this one. I knew this thing will mess me up. So I'll go to settings tab. Where? I'll scroll to the bottom. Delete this repo. Yes, I want to delete. I'll copy this. Choose my password. So yeah, it's deleted. Now let's do it in a clean way, because I think we had already messed it up. So let me just go ahead and confirm that we only have one repo here. So auth demo, we only have one Git. There's no other Git here. So let's go ahead and delete that one as well. All right, so how can you learn starting from scratch? The recorded sessions are on my YouTube. Just search Moses Mbadi on YouTube. You can see the recorded sessions. So let's repeat the steps for pushing to GitHub. Demo version 2. Create, and then we'll get all these, and then here readme, where was I writing? Here. So git init, and then we'll do that. All right, let's go ahead and paste it here. All right, I hope everything is okay now. So let's go to GitHub. All right, there seems to be an error. Commit branch remote add. Oh, the last command did not run, so we'll run it. Yeah, so after that is done, we can go ahead and see if it's here. Yep, now it looks clean. So let's copy it again. HTTPS copy. We go to the server, and then we say git clone. We paste it. All right, once that is done, we'll do cd auth demo. ls, we have cd frontend. We do npm install. Oh my goodness, what is not happening here? Why are you not? Huh? That's strange. That is very strange. That is very strange. Anyway, let's try the backend. So we'll cd dub. We cd into backend, and then inside backend we'll do. So since this is a server and other applications might be running on it, we need to create a virtual environment as well. So we'll do Python first to confirm Python is installed. Let's do Python 3. Okay, so to run Python here, you need to do Python 3. So we'll do Python 3 vnv Python 3 -m vnv venv. Python 3 -m venv. Okay, so okay, I think I will delete this server. So I'll just go ahead and ignore virtual environments. So I will do Python 3. No, let me confirm if pip is installed. Pip. We'll do version. Oh, that's strange. Okay, let me just copy this and paste it here. I have forgotten how to run these things on bare metal. So let me just go ahead and copy all these from right here up to, okay, I need to copy up to, I need up to this point. All right, and I'll go to Gemini and ask it what is happening here. There is pip not running. I'll hit enter. Let's see why it's not running. Whew, until I'm sweating. Ubuntu Quark on Ubuntu Debian-based systems, Python stripped down to bare essential blah blah. Sudo update. Alright, sudo apt update and that. So let's update our server. Our server is outdated. Sudo apt what is this? Sudo apt update. So we'll do and we paste that as well. So let's see what happens next. This has to be the longest class we've ever had so far. The other classes always end at 80 minutes, 70 minutes. This one is almost 2 hours. Oh, TikTok gang is complaining. Oh my goodness. So if you're on TikTok, I really would advise you shift to YouTube, because on YouTube the display is clear. It's displaying everything. Yes. Well, bet we are deploying a full stack application to a cloud server. That's basically what we've done. We are not really building per se, but we are deploying. And I am already hungry. All right, so let's go back to Gemini, copy this. We'll paste it here and see what happens. Yeah, so I think now our virtual environment is there. So we'll do source venv bin activate. Okay, so the virtual environment is activated as seen by this. So we'll go ahead and install requirements. Pip install -r requirements.txt. Yeah, there's one more command we need to run. Let me just delete this. We don't need it. There's one command right here. This one. Where? I thought. Oh, okay. We have another readme. Excuse me. So I'll copy this. We go back and run it as well. So remember, our backend will be running on port 8000, okay? And port 8000, so we'll say fast API dev. So our backend is running on port 8000, but we are not going to use localhost anymore. So if I take this localhost, it will be using what is running on my machine, not on the server. This is running on the server. So to access what is running on the server, we need the public IP of the server, which is right here, the public IP address. So I'll copy this, I'll go to the browser, and I'm expecting an error here. I'll show you why. I'll go to the browser and then I'll type 8000. So if I hit enter, it will take a few seconds. Yeah, there's really nothing loading there. Why? It's because I have not granted access on port 8000 on my server. So I will go and say add rule right here on IPv4 firewall. I'll say 8000, and then I'll say any IP address, and then I'll say create. So once that is done, I will go back here and again refresh. Okay, why 8000 any IPv4 address. Let's confirm where our backend is running on port 8000. On port 8000, and that is the 8000 we are accessing here. Let me try with incognito. All right, continue. What is happening? So to troubleshoot that, we can find out why it's displaying these three right here. So I can just copy this. I can copy it up to this point. All right, and I'll go to Gemini. I'll say my first API has these logs, but if I access it, using the server's public IP, it shows, what does it show? It shows page not reached. Okay, it shows this. I have opened port 8000 on my network settings. Now you see, yes, AI helps with this kind of troubleshooting, but you have to know exactly where the problem. Okay, not really you have to know where the problem is, but you have to understand what you're dealing with. Like, you have to be able to redirect AI to help you find that problem. So right here, I was pretty straightforward because I understand the concept of public IP addresses, and I also understand the concept of port numbers. So now it's telling me that this is how I need to run. Okay, so I'll copy this. I'll go back to my server. I will kill it with Control C, and I will paste whatever Gemini gave me. I will try again. All right, so once that is done, we'll go back to this thing here. We'll refresh. Still not working. Why? Oh, yeah. So now our page is working, but I have typed the wrong. So we had login, for example. Method not allowed because login is for post. But if we go to something like docs, we can see our backend is. Wait a minute, I'm doing the wrong thing. I was doing the wrong thing. This is where I was supposed to be. So I can do something like docs. And as you can see, our backend is running. So I'm not going to dive deeper into front end right now because it will take ages. But you can go ahead and test it out. I'll just paste the link in the chats. You can go ahead and test the backend. So the backend is working okay. Man, TikTok. Now I have to maneuver those pages. But anyway, so this is like an introduction to deploying applications to production. But you wouldn't expect an application like Soma Stories to be deployed like this. There's quite a few things missing. We don't have proper logging. We don't have proper error handling. We don't have even a load balancer. We don't have things like rate limiting. So our security is just it's open. Somebody can just crack this server and do whatever they want with it. However, there's only so much you can cover in one session. So I'm planning on having a full course which will be called DevOps, which basically will take you guys through how software or how web applications are deployed at production level, like at Facebook level, Safaricom level, all those things. There are things like CI/CD, there are things like Docker, there are things like logging, monitoring, containerization, Kubernetes. All that will be in that course. However, that course will not be as free as this one, because that one takes a lot of resources, especially cloud resources to do demos. Things like security, Vinny, we've not handled security here. So if you'd like to be part of that course, it will be a member only post. It will be a member only course on YouTube Live. You can go ahead and subscribe to be a member. I think there should be a link somewhere in my profile for you to subscribe to be a member. So it will be a member only course, and it will be an exciting course. We'll talk about performance, security, reliability of web applications and all that. And we will build a real world application using whatever we learn in that course. So do join, and I'll see you in the next class. So the next class will be on Saturday 8 p.m. as usual, but we will have an office hours either on Thursday or Friday. I will have an office hour session. If you're watching this on TikTok, I do advise you to use YouTube Live. TikTok is still a little bit junky and messy on my end. The setup right here took quite a lot of time to figure out. I think that's it. So there's a written version, a brief version of this course. You can find it on somastories.app. The link to Soma Stories is on my TikTok profile. It's also on YouTube. You can find the link, go through the guides. I have quite a few guides. For example, the Git and GitHub, building an authentication system, CLIs, algorithmic thinking, and all that. I think that's it. See you guys in the next one. Bye.